Hey everybody, today we will be going through learning target 4 once again, getting a little more practice in it, discussing some of the solutions and strategies to help you guys out before your final attempt at the checkpoint. So the first couple questions are true or false, and they are asking us about exponentials and logarithms. So the first one, part I, says that the point 1, 0 lies on every exponential function y is equal to b raised to the x power, where b is going to be a positive number. For this one here, we have a point and we have an equation. So you can always just plug in points to decide if it's true or false. So we know that b is any positive number. Let's just say that b is equal to 2. So if we plug this in, we have y is equal to 2 raised to the x power. And then we're given the point 1, 0. So let's see. Y is equal to 2 raised to the 1 power, because that's x. And from there, we see that y is just equal to 2. And the point that it gives us, 1, 0, tells us we should be getting a y value of 0. So from this, we know that this is false. This isn't true, since we found that y is equal to 2 when x is equal to 1. Part 2 asks us, or it tells us that the domain of the function y equal to the natural logarithm of x has a domain from negative infinity to infinity. And this one here is just knowing the definition of a natural logarithm. So we know that the natural logarithm of 1 is equal to 0, and that the natural logarithm of 0 is undefined. And something we talked about in class is that you can't have the natural logarithm of a negative number. So this answer is also false. Now we're asked to solve for x in 4 different equations here. First one being a regular logarithm. So we have log base b of 1 over b to the 12th equal to x. So just using the logarithm definition, let's write this as b raised to the x power, that x comes over here, that's equal to 1 over b to the 12th. Oh, whoops. Now getting this in the same level, as you could say, we'd have b to the x is equal to b to the negative 12th. Now we can pretty clearly see here that x is just going to be equal to negative 12, just from inspection right there. Now we have a trig question. Inverse sine of negative 1 equal to x, and we're going to solve for x. So it seemed like on the last checkpoint, everybody had a good general sense of what this might be, but the biggest slip up was knowing the domain of sine. So if we have a unit circle here, it never lets me draw a circle, I want to draw a circle. There we go. We have a unit circle, and we're looking at sine. So the domain of sine is going to be from negative pi over 2 to pi over 2. So in this realm right here, and we write this as negative pi over 2, this is 0, and this is pi over 2. So sine of x will be equal to negative 1. And negative 1 on this graph for a y value is right here. So x must be equal to negative pi over 2. Here we have a handful of natural logs. So the first thing I'm going to do is just try to get both of these sides in the form of one natural logarithm. So the left side we'll leave for now. It's in a pretty compact form. But the right side, we could use our exponent rules when it comes to natural logs. Rewrite this as ln of 2 to the 4th plus ln of 1. And something we talked about earlier, right here, right here, is that ln of 1 is equal to 0. So this just goes to 0. Now we have that ln of x squared is equal to ln of 16, because 2 to the 4th is 16. And then just from inspection right here, we can say that x squared is equal to 16. And then it's very important when we take the square root of both sides, we will have that x is equal to plus or minus 4. A lot of people miss that. That's very important since we're taking the square root of x squared. Just a little sidebar here. We did this by inspection where we said that x squared is equal to 16, but mathematically what we'd be doing is we would be raising e, the Euler's number, by the left and right side. So we'd have e raised to the ln 16 here. And then from here, with our rules where e to the ln of something is just equal to that something, then we could say x squared is equal to 16. But that's just a little bit of a mathematical notation thing. As you could see earlier, it's pretty clear that x squared will be equal to 16 since both sides are natural logarithm. But that's just a little note. This last part, part 4, wants us to also solve for x, and x is in a couple places here with a couple exponentials. So I'm thinking we should really try to simplify this left side down. So I'll write this as e to the 2x plus 1, and then distributing that cube, we will have 3 cubed times e to the 3x equal to 27. And 3 cubed is just equal to 27, so I'll write that as 1, and that will be 1. So now we have e to the 2x plus 1 times e to the 3x being equal to 1. And since we're multiplying exponents here, or multiplying bases, we want to add the exponents. So we will have e to the 2x plus 1 plus 3x equal to 1. Simplifying that a little bit more, we have e to the 5x plus 1 is equal to 1. And then let's take the natural logarithm of both sides, kind of like we did up top, just a little bit reverse, or as we did in part 3. So we will have natural logarithm of e to the 5x plus 1 equal to the natural logarithm of 1. Now, ln of e to the 5x, we can take that 5x, bring it out front, so we will have 5x plus 1 times the ln of e, and then this will be equal to 0 because ln of 1 is 0. And now ln of e is equal to 1. That's just definition. So we have 5x plus 1 is equal to 0. Thus, x equals negative 1/5. All right, one last part here, part C. I think you guys have seen a question that looks like this before on the last checkpoint. It's a very common one. It's a really good test of your exponent and root rules. All right, so as always, let's just try to get this in the simplest form possible by getting them all in fractional exponent form. So we have an a out front, and then we have an a to the 4th root, so a to the 1/4. This will be times b, and that b is cubed, and it has a 4th root. So because it has it's cubed there, and a 4th root there. This will be over our a is cubed, and it has a square root, so 3/2, times b, which just has that square root. All right, so that's a good step there, getting it all in this form. So let's just clean up that numerator a little bit to get it in terms of just 1a and 1b. And I'll just stick a to the 1 right here, just to make it a little easier to see. Since we're multiplying bases of a, we can add those exponents. We'd have a to the 1 plus 1/4, which is equal to 5/4. Well, at b to the 3/4 will still be the same. A to the 3/2 and b to the 1/2. Now that we have it in this form, we need to divide out these exponents, or divide out these bases, and to do so, we'll subtract exponents. So we'll have a to the 5/4 minus 3/2 times b to the 3/4 minus 1/2. make it a little easier to do this math, let's find common denominators for both those subtractions. We'll have 5/4 minus 6/4 times b 3/4 minus 2/4. And then from there, we are left with a to the negative 1/4 power times b to the 1/4 power. Yeah, so a bit of work goes into it, a good bit of algebra for sure, and just a general understanding of the rules. They're definitely very good to know, both for these checkpoints and your engineering careers. So it'd be good to nail this down, this next checkpoint. But if you have any more confusion, any more questions, as always, stop by office hours and let us know.